Welcome to Physics for Good. I'm Allison, and today I'm in Benson, Arizona, and I want to talk about ray diagrams. Now, usually by the time we get to this point in the semester, my students are very happy to hear about ray diagrams because now we get to draw a picture to solve a problem. So here's the setup for our ray diagram. Now before we even get started, the whole purpose of this is to say where is the image? And why do we want to know that? Well, if we're designing some system, maybe it's a camera, maybe it's a telescope, some optical system, we want to know where is the image going to appear because we want to know where we should put our eye, where we should put the film, something along those lines. So here is our mirror. In this case we have a concave mirror. And let's ignore this dashed line for the moment. We're going to come back to that. But for now, this is not the normal line. This is the focal point of the mirror. We talked about focal points last week. And this is the object. We represent an object in a ray diagram just by a little arrow. Okay, so this is also the optic axis, goes straight through the center of the mirror. And so we know there are, you can imagine lots of rays of light coming out from this object. Maybe this object is a light bulb or something that actually is giving off light, or maybe it's reflecting light diffusely. Either way, there is light either bouncing off or initiating off this object in all different directions. We only are going to pick two of those directions because all it takes is two to find the image. So, the first one we're going to pick is we know that a line that is parallel to the optic axis, a light ray that is parallel to the optic axis, is going to reflect through the focus. So let's draw that one. So we just need any kind of straight edge here. We're going to draw our line. And now here's where that dashed line comes in, because we're all going to draw the curvature of our mirror slightly different. So we're going to take our ray all the way to that dashed line, just so we're all on the same page. And then we know it's going to reflect through the focus. So we start where that is, and we're going to come through the focus. So there's our first light ray in our ray diagram. We know, we saw last week that a parallel ray to the optic axis is going to reflect through the focus. But we also talked last week about how rays that originate at the focus then reflect parallel. Well, our light rays are originating at the object, not at the focus, but we can look at the light ray that goes through the focal point, and then that's going to have to reflect parallel. So let's draw that one. And so if you just had to naively guess where you think the image is, probably most of you would say right here. And you're exactly right, because
images form where light rays intersect.
And specifically in this case, it's the reflected rays, right? Technically you could say, well, they intersect there, but these are not this is not a reflected ray. In here, it's this reflected ray and this reflected ray. And so the image forms where that ray intersects. And so there we have our ray diagram. We just solved this problem with drawing a picture. So this is where you would want to put your film or your eye or whatever you're using to capture that image created by this mirror. Now there are more rays you can draw, but personally, my personal opinion is that these are the two easiest ones because all you have to remember is the definition of the focus that we talked about last week.
Which brings me back to Benson, Arizona, specifically Benson Clean and Beautiful. I spoke with Lisa Hill and Cindy Allen about their work to influence community awareness, develop community pride, and help promote Benson as more of a tourist destination, specifically through murals. So Benson Clean and Beautiful is also drawing pictures to solve a problem, though admittedly their pictures are much prettier than our ray diagrams. That's due in large part to artist Doug Corliss. Benson Clean and Beautiful boasts more than 35 murals, with Doug as either the original or restoring artist. And you can see why, with the care put into these to-scale rendered drawings before the mural is even painted. I learned firsthand even more care that goes into this entire process, as they taught me how to prepare this wall for Doug to restore the mural. One of the first steps is to scrape away any loose material that could come off during the painting process. One thing Lisa and Cindy hope to accomplish is increased awareness of local attractions like Karchner Caverns and other natural, cultural, and historical sites, especially having to do with the railroad. To that end, they took me to the Benson Visitor Center, where I got to operate replica controls and act like a real train engineer. 3 horn blasts is a signal for going in reverse, which is exactly what the model train around the atrium of the Visitor Center did. You can control its speed and direction from the engineer's chair. And once you learn how, you get proof of your new skills. Because this is Physics for Good, 50% of the ad revenue generated from this episode will go to Benson Clean and Beautiful. So besides just watching this video, how else can viewers support you?
They can go to our website at bensonazmurals.org and click the donate button, or you can like and share our Facebook page, Benson Beautification.
And they can also buy or order online our Benson mural book, which shows all of the murals that we've painted and a summary of each mural.
Awesome. Thanks for watching. If you like what you just saw, please consider subscribing right here and sharing the video with a friend. Also, check out the video description where you'll find a link to the charity you just saw, as well as some affiliate links.